Okay, so this is our third lecture video for this lecture series on oscillations and waves. So, we now know two different kinds of oscillations. First is the idealized type, which is the simple harmonic motion, wherein the amplitude of the oscillation is constant all throughout the motion. And second, we've also discussed about damped oscillation, wherein the amplitude of the motion decreases with time. Now we have here the third type of oscillation, which is the forced oscillation. So for this lecture video, we will discuss forced oscillation and let's relate it to the concept of resonance. Okay? So let us first get to know the two types of frequencies. So first we have the natural frequency and the second, the driving frequency. So the natural frequency is just the frequency at which a system naturally vibrates once it has been set into motion. So let me show you a video that demonstrates the natural frequency of a glass. So what you've heard is actually the natural frequency of a glass. So if the amplitude of the vibrations are large enough, and if the natural frequency is within the human frequency range, then the vibrating object will produce sound waves that are audible to human ear. While on the other hand, the driving frequency is just the frequency of the driving force. If we apply a periodically varying driving force with angular frequency to a damped harmonic oscillator, the motion that results is called a forced oscillation, or this is also called as driven oscillation. So it's just very simple. You just exert a driving force. As an example, we have this one. So as you can see, the girl is pushing the boy on the swing, and the girl is actually exerting a driving force, thus forcing oscillation into our swing. So let us now consider two cases. For the first case, let the natural force, or the natural frequency rather, to be equal to the driving force. So observe what happens to the swing. So in this example, the swing has its own natural frequency, and the pushing motion of the person in the video causes a driven oscillation. So when the driving frequency or the driven frequency is faster or is lower than the natural frequency of the swing, the amplitude that it moves to is just very small. Now, what do you think will happen if the natural frequency will equal to the driving frequency? Or meaning to say the person will match its pushing force towards the swing to be equal to that of the natural frequency of the swing. So observe what happens. So as you can see, the swing was able to reach a higher amplitude compared to the one on the left-hand side wherein the natural frequency is not equal to the driving frequency. Therefore, a force applied at a frequency which closely matches the natural frequency of the pendulum causes the amplitude to increase. Okay? And this is actually the phenomenon that causes resonance. Okay? So again, resonance occurs when we force a system to vibrate or oscillate at its natural frequency by a periodic input of some external driving force. Okay? So, again, observe this video. So if you want to increase your amplitude, okay, so if you want to increase the amplitude of a natural oscillation, then all you need to do is to exert a frequency that closely matches to the natural frequency of that body's oscillation. Okay, so I hope that's clear because that ends this lecture video, and I will see you on the next lecture video, which will be about waves. If you have more questions or if you want more examples, then do not hesitate to ask your instructor.